Okay, so for today's lesson, we will talk about the properties and application of the Fourier series. So this is the outline. So what is the Gibbs phenomena? Okay, what is the Gibbs phenomena? How is a symmetric? And the response of the LTI system, okay, linear time invariant system to a periodic signal. And also we calculate the power and Parseval theorems. And lastly is the circuit application. Okay, first of all, we look at the Gibbs phenomena. What is the Gibbs phenomena? If you look at this figure, you will definitely see there's a different sinusoidal wave. Okay, this is one sinusoidal wave. Okay, and then there's another sinusoidal wave. It's another more and more, getting more and more. Okay, so this signal plus this signal plus this signal, which equal to another signal. So the Gibbs phenomena say that as more and more Fourier components are added, the sum get closer and closer to the original waveform. So most probably it tried to say that the combination or the summation of the single waveform sine wave with different frequency sum up together, it may produce near to the original waveform. This original waveform could be the square wave. Okay, the square wave. Okay, so I think this AC and DC is quite familiar to you since you have learned about the Fourier series in trigonometry form. So in trigonometry form, you learn what is DC and AC. So DC is the A naught, AC is the AN and BN. Okay, so this is the DC and AC component. AC is AN and BN. So here I want to show you that this is the sum of the two AC component. Okay, AC component AN and BN. Okay, sum of the first two AC. Okay, and this sum of the first three AC, because we have multiple sinusoidal wave with different frequency, where we sum up together, we have this harmonic. Okay, this is, we call it harmonic. Okay, if you look at more again, so if you look at this one, is 2 AC, this is 3 AC. What if more? This is 4 AC, this is 5 AC. So you look at the harmonic here. Okay, the harmonic here. This one is 11. Okay, 11 AC component, n equal to 11. So actually, if you look at this is more or less like the square wave. Okay, so that's why in this Gibbs phenomena, it said that more and more frequency component add up together, then the sum, means that the output, the sum will get closer and closer to the original waveform. So this one, this FT, we have the square wave. This one is the original waveform. So if we have more and more AC component that sum up together, this will similar to the original waveform. That is what we means in the Gibbs phenomena. So this is another example of the Gibbs phenomena, which is this one. The gray color one is the original waveform. First of all is one components only, and this one is three components. Okay, three components. Okay, so you have the harmonic. You can see the harmonic already. So this is a sum of the five harmonics components. So you look at the harmonic is getting closer and closer. If this one is more than 50, so 51 components. So it's more or less like the square wave that from the original. Okay. Are you clear with this class? Any question want to ask about this Gibbs phenomena? If no, I move to the second part of this topic, that is symmetric. So the symmetric consideration is to simplify the calculation needed to determine the Fourier coefficient. The three considerations are even, odd, and half-wave symmetric. So the most common one is the even and odd. Okay, most common one is the even and odd, like we study in the chapter 1. Okay, what is the even symmetry and odd symmetry? But in this here, we also add out another half-wave symmetry. Okay, everyone should know that even symmetry, that the xt is equal to x negative xt. This negative xt means the signal is a mirror image at the y-axis. Okay, only one time, mirror image at the y-axis. Whereas the odd symmetry is x negative t equal to negative xt. So if you still remember, okay, I told you that odd symmetry is the 2 times of mirror image. First, you mirror image at the y-axis, and then mirror image at the x-axis again, so you will get the odd symmetric. So this one you already learned it in the previous chapter. Whereas the half-wave symmetry is xt minus capital T over 2 or equal to negative xt. Later I will show you what is the half-wave symmetry. Okay, let's review back what you have in the even symmetry. Okay, so a function of xt is even if xt equal to x negative t. So you know that the xt is mirror at the y-axis, ft is the y-axis. So if even symmetry, what is the Fourier coefficient? Okay, this one actually is to make your life easier. Okay, why I say make your life easier? Because if you know that the signal given in the question is even symmetric, automatic Bn is equal to 0. Okay, here it said that simplify the Fourier coefficient become, okay, and not you need to calculate, and you also need to calculate Bn is 0. This means that for even symmetric, Fourier coefficient for the Bn is 0. Okay, for the Bn is 0. This means that you don't need to calculate the Bn for even symmetric lah. This is even symmetric. For odd symmetric, okay, so this is the equation for the odd symmetric double mirror image. First is at the y-axis, then followed by the x-axis. So for the odd symmetric, it's even easy. A not equal to 0, an also equal to 0. You only need to calculate the Bn. Okay, so because even you calculate, this will contribute to 0. Even you calculate for long, at the end, 0. Okay, let's say you already know that the question given is the odd symmetric graph, like this, odd symmetric graph. You can say, okay, based on the odd symmetric properties, an and a naught is equal to 0. So you only calculate Bn. You no need to waste time to calculate the a0 and an, and now you just get 0. So this is make your life easier. All right. So this is the odd and even. Lastly is the half-wave symmetric. Okay, half-wave symmetric is the function of st is the half-wave symmetric if this one negative t plus minus t naught over 2 equal to xt. Okay, so this is the simplified of the coefficient where a not only equal to 0, okay, and an, so means that a naught you don't need to calculate because a naught is 0. An for even is 0, for bn even also 0. This means that you only need to calculate the an and bn for odd value only. For even you will get 0, 0. Okay, so also make your life easier lah because you save 3 calculation. Okay, function that is odd but without half-wave symmetric. Okay, if you look at this one, this function is odd but without half-wave symmetric. Okay, what about this one? Do you know what is half-wave symmetric? Half-wave symmetric is just like, okay, if you this one, initially maybe I draw a little bit. Okay, half-wave symmetry Okay, initially is this figure, this line, this one. You see my cursor. First of all, is this line. Okay, this is the line of the signal. If half-wave symmetry, this means that it will, how to say, it shift to the left and mirror image. How to say? Wake up. This one I wake up. Right? If we read, let me see. Is there any graph? I want to show you some graph. Okay, this one. Okay, this graph, if you look at the blue color, this blue color is the line, right? If half-wave symmetry, this means that this line, okay, this blue color line, this one, this line, okay, it will move a mirror image, not mirror image, it will move to the left hand side, move to the left hand side, and then mirror image at the right hand side, and mirror image at the x-axis. So this one, okay, like this. Okay, so this graph will move to the left, so you will get like this. Okay, but mirror image, it only mirror image at the x-axis. Okay, because of the negative here, right? Mirror image at the, so let's say if this one you have after move to the left, mirror image of course is this one. You mirror image at the x-axis, so your mirror, you get this one. So that is so called the half-wave symmetric. Okay. Okay, for the, so this is the table summary. Okay, summary of the half-wave symmetric and even and odd. Okay, if even, you only need to calculate A naught AN. For odd, you only need to calculate BN. For half-wave, you only need to calculate for the odd of the AN and BN. So this is the summary of the symmetry properties for even. And for odd, okay, for odd, even is you only need to calculate BN. For odd, you calculate for the A odd and AN. Okay, so as a proof, okay, maybe you can go to the exercise example 3.12. That's proof the property even and odd properties. You go to example 3.12. Okay, you go to page 129. Okay, you go to page 129. Okay, this question. This one is odd or even, class? This is odd, right? Okay, this graph, it looks like odd. Okay, for the odd, A naught, okay, 0. AN, you have value. Or AN also 0. A naught, 0. AN also 0. You only need to calculate BN. Okay, BN even. BN odd only. So this so this one is actually you already proof that the odd properties, okay, in the Fourier series coefficients. Which one you need to calculate, which one you don't need to calculate. Okay, not symmetry. If you go to the not example 3.11, not symmetry, you will get a not equal to n equal to 0 for n equal to even. Okay, let's go to example 3.11. Okay, 3.11, this is not an even, not an odd. Okay, so you only need to calculate for the a not, okay, and then bn even, bn odd, okay, because an you get 0 and bn even you also get 0. Okay, this is what we prove in the not symmetric. Okay, this is the Fourier series for selected signal. Okay, so this one is let's say if but normally we seldom, this is just an example lah for the Fourier series of selected signal. Let's say if I have the signal like this, the square wave like this, what will be the signal xt? Okay, of course, how to get this one is you need to calculate starting from a naught, an, and bn. Then only you can obtain this one. This one is just an example. If this signal looks like this, what will be the xt? Okay, if this signal looks like this, what will be the xt? But however, you still need to calculate lah. This is just an example only. If this signal, okay, is a round shape one, so what the xt will looks like for the sawtooth wave, okay, this is the signal. Okay. Okay, class, any question before I move to the LTI system? Class, is there any question before I move to LTI system?
So far, no, Doctor. No, Doctor.
Okay, but this more or less is more to the properties lah. Alright, for the next one is the response of the LTI system. That periodic to signal. If xt is the impulse response of the LTI system, then the system response to a complex exponential is a complex exponential with the same frequency and a change of amplitude. Okay, what does it mean here? He said that if x ht is the impulse response, okay, you know that what is impulse response, right? Ht is the impulse response of the LTI system. Then the system respond to a complex exponential is a complex exponential with the same frequency, okay, same frequency but change in amplitude. Okay, the main point here he want to tell you is the complex the output the system response is the output is the complex exponential, okay, in the exponential form with same frequency, okay, frequency no change and change in amplitude. Okay, later I will show you the example. What do you mean by change in amplitude and same frequency, right? So the response of the exponential is the exponent power of j 2 pi f naught t, okay, is hash f naught. So this is the frequency that we are talking about, same frequency. So we always refer to the same frequency. Okay, so these are the response for the hash f in frequency domain and in j omega domain. Okay, if xt is periodic with period t naught and has a Fourier series expansion, so xt if equal to summation of the xn. So this one actually is the Fourier series, exponential Fourier series. Okay, and this L is referred to LTI, not the Laplace transform. Okay, this L is referred to the LTI. Okay, not the Laplace transform, the symbol here. Okay, I want to show you his okay, this one. So we have the input xt. Okay, input xt is the, we need to find the xn. Okay, summation of the xn. This one is the exponential. Insert into a system to produce the output, right? To produce the output. So this output is using the frequency. Okay, frequency just now the hash f, the frequency. So here we say that if the input to LTI is periodic with period t naught, the output is also periodic. Okay, let's say the input to the LTI is periodic, means the output also should be periodic. And then we need to calculate the YT. From the YT, we know that the Yn is Xn hash and F naught. Modulus, this is the amplitude, and this is the phase. Okay, if I explain to you now, it looks like quite complicated how to do all this. Okay, later I will show you the example, don't worry. Okay, only frequency components that are present at the input can be present at the output. So LTI system cannot introduce new frequency component at the output. So we only follow the frequency component given in the input only, given in the question only. We cannot introduce a new output. And the amount of the change in amplitude and phase are function of n and harmonic order, and the ht is the impulse response of the system. Alright, let's say we look at the example. It should be easier to understand instead of you read the statement. Okay, we go to this example 3.2, or you can refer to your notes, which is in page 146, example 3.15. The signal xt with the period t not equal to 10 power of negative 5 seconds. So just now I said, if the input is periodic, the output should also periodic, right? So now you said that the signal xt with period t naught means that the signal is repeated again and again, okay, for t naught equal to 10 power of minus 5 second in figure 1. So this one, this is the t naught, okay, with the value is this one. And then this figure 1 pass through a low pass filter with a frequency response given in this. So this is the frequency response. So you need to determine the output. Previously in the exponential Fourier series, we only calculate what is the full exponential Fourier series if I give you this graph xt, this input. What is the difference between LTI response is that this input you have to pass through a system, right? The system, this system is a pass through a low pass filter lah. Okay, and the characteristic of the filter is this one. This is the frequency response, and this is the amplitude and the phase. You need to pass through these things. This is the low pass filter lah. That's so called the low pass filter. What is the output? Is that this input pass through a low pass filter with this characteristic? What will be the output? You understand what is the question want you to do? You need to understand the question first before you can continue. So before that, you have to calculate this one. But today or this morning, I won't teach you how to find this one because you already know. So I only will take the answer from the previous example. So last time we stopped at the exponential Fourier series, so we will just get the final answer of the exponential Fourier series, and then pass through this filter to get the output. Alright, so I will stop sharing and I will share another screen. Can you see my screen?
Yes, doctor.
Okay. So we go to the previous example. So if you look at the page 146, example 3.15, okay, page 146. Okay, page 146. So it said that from the previous example, okay, from the previous example, we obtained the xt equal to alright, so from the previous example, we know that the xt is equal to 2 over pi exponent j pi t plus exponent minus j pi t, and then minus 2 over 3 pi exponent j 3 pi t plus exponent minus j 3 pi t, okay, and then plus with 2 over 5 pi. This one is more to the odd value only, okay. Okay, then you minus something lah. So from here, can everyone tell me what is the omega naught here? Okay, if you look at the graph, we want to find out what is the omega naught. Let's try to find out. Omega naught actually is 2 pi over t naught, right? So t naught here, if you look at the figure, if you look at the question, okay, so this t naught, this is not clear. Perhaps you can look at the knots module. Module 146. In module is clearer, it mentioned 2. Okay, so one cycle is starting from here to here. So T naught actually is 2. Okay, T naught actually is 2. So 2 pi over T naught. So T naught is 2. So this will equivalent to pi only. Omega naught is pi. Okay, so now from here we know that the omega naught is pi. Okay, so this one actually is referred to omega naught. This one is 3 omega naught. This one is 5 omega naught. Okay, so I write it here. This one is omega naught. This is 3 omega naught. This is 5 omega naught. Okay, because it's the one is the omega naught value. So okay, now we can from the exponential here, we can convert into a cos or sine. So class, can you tell me what is this equation can convert to cos or sine? Is it cos or sine? Can anyone tell me? No idea? It should be cos, right? Because cos theta equal to exponent j theta plus s minus plus exponent power of minus j theta divided by 2. Because we don't have the j here, so we use the cos instead of the sine. Okay, so here we can convert to the cos. So now we convert to the cos. Okay, so this part we can convert to the cos. Okay, but we only have, okay, this part we only show here. So now we only this part we only have like this. So now we need to have exponent j theta. Okay, this part we can change to cos. Okay, cos 2 cos theta or 2 cos omega naught. Okay, so 2 times 2 over pi, you get 4 over pi cos pi t lah. We follow back cos pi t, and then minus this one, this part also the same. You 2 over 3 pi, you multiply with 2 cos 3 pi, so you have 4 over 3 pi cos 3 pi t. and then plus with this part also the same. Okay, 2 over 5 pi multiply with 2 cos 5 pi. So you have 4 over 5 pi cos 5 pi t. Okay, so if you stop like this, also no problem lah. You no need to have the last one. You stop like this also. Okay. Okay. So now you want to find the output, okay, for each frequency. So just now you already know that the f omega naught is referred to pi. What about the f naught? Okay. F naught is referred to T naught, right? 1 over T naught. So you in the question, you already know that T naught is 10 power of minus 5 per second. So 1 over 10 power minus 5. So this will get 100 kilo. Okay, 100 kilohertz. So we are looking for the 100 kilohertz. So to find the output, for this each 100 kilohertz, so we must multiply the coefficient of this frequency component. Okay. So let me draw first. Let me draw this one. Okay, this is negative 600. This is 600. Okay, and this is the amplitude, and we also have the phase. Okay, this is pi over 2. Another one is negative pi over 2. Okay, so we base on this one to do the calculation. Okay, so we need to find the hash f. So hash f is referred to hash. So the frequency just now is what? 100k, right? 100k, or we can say that is 10 power of we have the positive and negative. Why we said this is the positive side and we have the negative side? So we have two value, positive value and negative value. Okay, so now we look at the positive side first. So this is positive side lah. Okay, we look for 100k. Okay, we look for 100k. So what is the 100k? Should be maybe something like here. Okay, if 100k, what is the value? Can anyone tell me? 100k. So this is 600 with 6. This is 600 with 6. So it's a square. So for sure, if this is 100k, for sure this is 1 only. Okay, so you have 1. What about if we look at the left hand side frequency, for sure the phase also look at the left hand side. Okay, so this one is continuously pi over 2. So we have the phase is j pi over 2. It's a positive. Okay, positive j pi over 2. Okay, so this is the positive one. What about the negative one? This is a positive side. What about negative side? The negative side, you have hash negative 100. So negative 100 is here. This is negative 100. So you also get positive 1. But the phase is negative. Why negative? Okay, you refer to here. Amplitude is the same, so that's why it's 1. But the phase is refer to the value here. It's negative pi over 2. Alright? Okay, this was clear or not, class? I want to know that this one is clear, or do you have question before I move to the next frequency?
Doctor, could you explain again the h to 10 power 5?
H to 10 power 5. Okay. First of all, if you want to know which frequency you want to take, you have to find out what is the f naught. What is the F naught? Okay, so that's why I find out the value here. Okay, F naught equal to 1 over T naught. In the question already given to you, T naught is 10 power of minus 5. So what is the F naught? Easily, F naught is 1 over T naught. T naught is given, so you get 100k. So what is the purpose of this 100k? This 100k is for you to find out, okay, what is the value of the amplitude. You want to take the value of amplitude and the phase here, okay. So you won't simply take I want to take 150k. You cannot. You have to refer to what is the question given. Okay, if question given T naught different value, of course it's not 100k anymore. So now in this question given T naught is 10 power of minus 5, so you get the T naught is 100k. Okay, so you get 100k, so you need to get what is the, you need to read, because this amplitude here, you see the frequency, right? So 100k, this one is 100k lah. This one is 100k. Look at kilohertz, right? 100k. So this part is 100k. So I need to read the value. What is the value of 100k here? The amplitude is what? You have for the refer to 100k. What is the amplitude I get? Positive 1. So this is the 1 here. And since this is the amplitude, what is the phase? The phase is pi over 2. Because the left hand side, right hand side graph, you also refer to a right hand side graph. So the amplitude, the phase is pi over 2, positive. So exponent j pi over 2. Okay, for the right hand side, because this 100k, you have the positive value and negative value. Okay, so this negative value is negative 100k, the amplitude also 1. Okay, this is the one here. And then the phase, okay, you refer to negative pi over 2. So actually everything you is what you want to get the value is depends on the graph. Okay, this response given by the question. Let's say I only have this graph. I don't have this one. I only have the positive graph given by the question. So I take this positive value lah, positive graph only 100k. I don't need to bother negative. But now the question is different. The question is you have positive value and negative value, so you need to consider both. Do you get what I mean here? So are you understand? Is there any question you want to ask before I proceed to next frequency? Or next frequency can make you more understandable? If no, then I talk about the second frequency. Okay. Okay, before you go to second frequency, you have to check what is the xt in the previous, okay, in the you obtain here. What is the xt? If you look at the xt, it only refer to what? Odd value or even value? If you look at here, this one is the 1 pi, 3 pi, 5 pi. This means that it's a odd value. So this means that we are not every value, every pi we take. We only take the related. So it's you still have to refer to the xt calculate before. So this one is available. If for 1 pi, 3 pi, 5 pi, like for example 2 pi, 4 pi, 6 pi, what is the answer? The answer is 0. Okay, because we have to refer to the xt. Okay, so now we know that we only take the odd function, odd value. So of course we no need to calculate for the hash 200. So we calculate for hash 3 pi, okay, or 3 omega naught, or we say that is a 300k. Okay, is 300k. Okay, 300k, or I change to 10 power of 5. This one also refer to 300k. So 300k, what is the reading? I use different color. So roughly half of this is the 300k. So 300k, I move up and I move up here, I should get 3 lah, for the positive value. So I get 3 amplitude, and the phase I still refer to the positive side, so it's the exponent j pi over 2. For the negative side, okay, is this is negative 300. Okay, I still obtain the positive amplitude, but the phase I obtain negative. Okay, okay, and then after you have 100k, 300k, what is next? Okay, for the odd is 1357, right? So we can go for the 500k. So 500k is nearly about here. Okay, so 500k, you will get 5 also. So amplitude is 5. Of course, the phase is still the same because you refer to this side of the graph. Okay, and then negative 500k is refer to 5, amplitude is 5, but the phase is negative. Okay, what is next? 1, 3, 5. What is next, class?
7.
7. Okay, so if you look at the 7, okay, no, okay, I want to do the 700. Okay, 700, if you look at the graph stop at where? The graph stop at 600 only. So 700, what is the value?
0.
0.
So do you think that you need to find out?
No.
No.
No need, right? Even though you have the phase here, but don't need, because everything when you multiply with 0, you obtain 0. So 700, no need to do. Okay, so actually the value is still depends on the graph of the amplitude hf. Okay, you get what I mean here? So after this, what happened? Okay, so you have all this value, so you can substitute in here, substitute in the xt. So yt equal to 2 over pi. Okay, we refer back to the previous one. 2 over pi exponent j pi over 2. Okay, we copy back for the, okay, if you refer to the yt, so it is 2 over pi. Okay, exponent j pi over 2. J pi over 2 is this one. Okay, exponent j pi over 2, and then exponent j pi t plus exponent minus j pi over 2 exponent negative j pi t. Okay, I let you compare what is the difference. Okay, so the different part is you add this one. You add this one. Why black color already? You add this one, which is referred to here. Okay, let's continue. And then minus with 2 over 3 pi. So you want to add this one, so it's 3 exponent j pi over 2 exponent power j 3 pi t plus 3 exponent minus j pi over 2 exponent minus j 3 pi t. Then plus with 2 over 5 pi phi exponent j pi over 2 exponent j phi pi t plus exponent phi exponent minus j pi over 2 exponent minus j phi pi t. Okay, again, I want to highlight to you. Okay, this one is referred to add here. This part you add here, and this part you add over here. For this part you add over here. Can you see it now? Okay, class, up to now, okay?
Okay, doctor.
Okay, so after that we continue, just simplify only. We just need to simplify. So equal to 2 over pi. So you simplify this part, you get exponent j, okay, pi t plus pi over 2, okay, plus with exponent. So this is a minus j, you take out the minus j, so you have pi t plus pi over 2 also, okay, then minus with this one can cancel out, negative positive 3 cancel out, you get 2 over pi. Then you have exponent j, okay, you take out the exponent, so you have the j 3 pi t plus pi over 2, then plus exponent minus j 3 pi t plus pi over 2, okay, and then plus with 2 over pi, because cancel out this one, so you left exponent j 5 pi plus pi over 2, 5 pi t, okay, plus with exponent minus j 5 pi t plus pi over 2. Okay, so you just simplify. Okay? Okay, class, understand? Any question want to ask for about this question? So that's it. This is the output. After you simplify, you get the output. Is it okay, class? Any question to ask? Any question?
No, doctor.
Okay, if no, then we take 5 and then we continue again. We take 5, then we continue.
Okay, thank you, doctor.
We start again for the example 3. Okay, we finish example 3.16, and then we finish example 3.15 and 3.16 with different signal, but doesn't mention what kind of signal in 3.16, but it only show what is the frequency response for this example. Okay, seems that the frequency response is the same. Okay, and also Tina also the same, but the given input xt is different. Okay, if you look at the xt here is 1 omega naught, 4 omega naught, and 8 omega naught. This means that we will tap the signal at 1, 4, and 8. if compared to the previous example, okay, previous example, the xt here is 1, 3, 5, right? Okay, 1, 3, 5. Okay, we tap the signal at the 1, 3, and 5. Okay, for 3.16, okay, for example 3.16, okay, we previous solution is refer to a 148 omega naught. So what we need to do, we tap at the frequency at 100, 400, and 800. Okay, so of course you need to calculate what is the f naught first lah. Okay, so 1 omega naught, 4 omega naught, and 8 omega naught. But if you look at here, okay, let's say the question need you to tap at 148. If you look at the frequency response here, the amplitude here, 1,4 is in the range, 800 is out of the range already. So this means that the 800 here you will get 0. So no matter you multiply with 0, you will get 0. So 800 is no value. You only have value at 100 and 400k. So therefore 100 and 400k you have the value for positive and negative side. For 800 they will get 0. This one clear or not, class? Is it clear? Hello? So if you have silent, I assume that you can catch what I mean here. Okay, then we go to the example 3.17. So this is the voltage source given by the question. Okay, this is the voltage source given by the question. And then it said that if this signal V in become the input to the LTI system, express the output of the system V out. Okay, so the frequency response in this example is slightly different lah. Okay, so we need to refer to this frequency response. Alright, so first of all we need to find out what is the F naught. Okay, do you prefer me to write down or explain like this? I think maybe I write out lah. Okay, example 3.17. Okay, so first of all we need to know what is the F naught. Okay, if the question given by the question is V in equal to 10 plus summation of n from -3 n not equal to 0 to 3 j 1 over n pi exponent j n pi 100k t. Okay, this is the equation. So you need to find out the V naught, F naught first. So F naught is start from where? Omega naught, right? So 2 pi F naught equal to this one. Okay, so you get pi, 2 pi F naught is pi 100k. So F naught is pi 100k divided by 2 pi. So cancel, this one is 50, so you get 50 kilo. Okay, 50 kilohertz. Okay, so you need to calculate, always need to calculate what is the F naught. It's not necessary each time is 100, 200, no, you have to calculate. Okay, so from here you know that the F naught is 50k. Okay, so okay, this one you have the frequency response. negative 125k to positive 125k. And this is the phase. Okay, so now we want to tap at which one? So let's say H0 means that at the A naught, okay, A naught, H0 means you want to get the A naught. What is the A naught here? A naught here, if you refer to this equation, A naught here is 10. Okay, this is the A naught. You got 10. Okay, 10, but for A naught, the frequency of course is 0. So H0 is 5. So this is the value of 5. And then you want to find H1 F naught. Okay, F naught is 50k. 1 F naught, so it's 50. 50, you have a 150 here. So 50 is nearly somewhere here lah, maybe 50k. So this 50k, what is the amplitude? You get amplitude 5. And the phase here is pi over 2. So for the negative 1 F naught, so it's here. So negative 50k, you get 5 also amplitude, but with the phase is negative j pi over 2. Okay, and then you have F2 F naught. Okay, so at 1 F naught is 550, 2 F naught is 100. So 100 about here. Okay, so you also get 5 amplitude, and the phase is pi over 2. For negative 2 F naught, also the same, you have the 5 as the amplitude, and negative pi over 2 is the phase. And then H3 F naught. Okay, so 3 F naught, 3 times 50, you get 150. Okay, 150, oh, 150 should be here already, 150. So I will get 0 here. Same to 150, I will also get 0. So this means that I cannot get any value, so I will get 0. So H negative 3 F naught, well, I also will get 0. So I only have this 3 value. Okay, so the question asks you express the output of the system V out. Okay, so you want to find the V out. Okay, V out at 0 F naught. Okay, 0 F naught means when F naught equal to 0, you have the input V in. Okay, and then at 0 F naught, multiply with the hash at 0 F naught. Okay, V in, you have the value of 10. Okay, V in, you have the value of 10. This is for the A naught lah. V in, you have the value of 10. And then F naught, you have the value of 5. Okay, you have the value of 5. So multiply with 5. So you get 50. What about V out at 1 F naught? So you want V in at 1 F naught, multiply with the hash at 1 F naught. So V in at 1 F naught is, what is the value? V in at 1 F naught. Okay, this. Okay, j over n pi. Now n is 1, so j over pi only. Okay, j over pi only. J over pi, and then hash 1 f naught is this value. So it's 5 multiplied with j pi over 2. Okay, this j over pi, okay, if you draw the imaginary part, because j is the imaginary part, okay, so you have this kind of things. For imaginary, we know that j over pi is 90. Okay, 90. So this one will be 1 over pi. The value is 1 over pi. This is 90 degree. And we can simplify into, if j over pi, we can simplify into exponent j pi over 2 multiplied with 1 over pi. So you will say 1 over pi multiplied with exponent j pi over 2. Okay, the j here, let me see. Okay, the j here is referred to this part. Okay, 1 over pi is still remain 1 over pi. Okay, and then you multiply with the same things, 5 exponent j pi over 2. Okay, so this one you combine, you can get j pi only. So 5 over pi exponent j pi. Okay, and then you want to find for the V out for second 2f naught. So V in 2f naught multiply with hash 2f naught. So V in 2f naught. Okay, again, just now is j 1 pi, so now is 2, right? So it's j over 2 pi. Multiply with the 2f naught, you get 5 exponent j pi over 2. Okay, again, this one you change, you get 1 over 2 pi, you multiply with the exponent j pi over 2, multiply with 5 exponent j pi over 2. So you simplify, you get 5 over 2 pi exponent j pi. Alright, so next is V out 3f naught. You have 3 in for 3f naught, multiply with the hash of the 3f naught. V in 3f naught, again you will get j over 3 pi. Hash f naught, what do you get? 0. Okay, you multiply with 0. Of course, you will get 0 lah. So this is the positive side. What if negative side? So all the V out at the positive, we want to calculate for the V out at the negative side. So V out at negative 1 f naught, we have V in at negative 1 f naught, multiply with the hash negative 1 f naught. So we still obtain j over a negative pi, because it's a negative, right? So negative pi, and then we calculate this one is still same as 5 exponent negative j pi over 2. So we copy down 5 exponent negative j pi over 2. So I simplify. Okay, so it's still negative 1 over negative pi. Okay, exponent minus j pi over 2 multiply with 5 exponent minus j pi over 2. Okay, okay, so this will, okay, they So bear in mind that j over negative pi also equal to 1 over pi exponent minus j pi over 2. That's why you can get a positive here. So it's positive 1 over pi. This is positive. Positive 1 over pi. Okay? So you simplify, you get 5 over pi exponent minus j pi. Okay, next we calculate the V out for the negative 2 F naught. V in negative 2 F naught multiply with the hash at negative 2 F naught. So you have j negative 2 pi multiply with 5 exponent negative j pi over 2. So this one you can change into 1 over 2 pi exponent minus j pi over 2 multiply with 5 exponent minus j pi over 2. So you can simplify, you get 5 over 2 pi exponent j minus j pi only. So for the V out at negative 3 F naught, you already know it is multiply with 0, so of course you will get 0. Okay, so lastly you combine everything. Summation from negative infinity to infinity, V out n, okay, V out n from exponent jn 2 pi ft. So we just combine everything starting from V out 0 F dot. So you have 50 plus 5 over pi exponent j theta. Okay, this one. You have to combine everything. So 50 plus 5 over pi exponent j theta. Okay, this is the V out. Okay, this is the V out. Okay, n when n equal to 0. Okay, so you obtain this one. Okay, and you have to substitute this part also. Okay, exponent j now is n is assumed when n equal to 1. When n equal to 1, so you have 5 over pi exponent j pi. Okay, is the V out. Okay, V out at 1, positive 1 F naught. And then you substitute, okay, exponent j 2 pi. Oh, sorry, n is 1 pi only. N is 1, so you have still have 2 pi. F naught is 50. K, 50k t. Okay, then plus with V out 2. V out 2 you get 5 over pi exponent minus j pi. Okay, V out 2. Okay, let's go to V out 2. Okay, this one. Okay, V out 2. Or you can write in another way also can. This one is positive 1 F naught, right? You can rearrange it into negative 1 F naught. You also can. So we use this one. Okay. This one is a negative 1 when n equal to negative 1. Okay, so we have exponent j negative 1 pi exponent negative j pi no negative 1 2 pi 50k t. Okay, plus with, okay, then now it's 2 pi, so 2 F naught. So 2 F naught you have the value of 5 over 5 over 2 pi. So this is for the n equal to 2. For n equal to 2, you have this one only, j pi only. And then exponent j, you substitute using this formula. N is 2, okay, 2 pi and then 50k t. Okay, then plus with negative 2 f naught, so you got 5 over 2 pi exponent minus j pi exponent j, okay, minus 2 pi, okay, 2 f naught is 50k t. Okay, so plus with 3 is 0, so that's all. Then you can simplify, you get 50 plus 5 over pi ej, so you can combine everything. Okay, 2 pi 50k, so it's 100k pi t. This one is pi, so pi plus 100k pi t plus 5 over pi exponent minus j pi plus 100k pi t. Okay, plus with 5 over 2 pi exponent j. So now you have pi plus 222, so it's 200k pi t. Okay, plus with 5 over 2 pi exponent minus j pi plus 200k pi t. Okay, so that's it for this V out. So any question, class? Are you able to understand? Is it okay?
So far okay, Doctor.
So far okay, huh? Okay. Then you need to do some exercise for page 151, exercise 3.4. Can you do question 1 and 2? Question 1 and 2. This one I give you 2 weeks lah, because next week is test week, so I don't want to interrupt your test, so you can after the test only can do. So I give you until 22 of November to submit.
December, Doctor.
Sorry, December. 22 of December to submit 2 weeks time, because next Thursday is the test, so perhaps you need to do some revision for the test, so I don't want to disturb your revision time, so I give you 2 weeks. Okay, Q1 and Q2 for the exercise 3.4.
Thank you, Doctor.
Okay, welcome. Okay, next will be the, let me see what else we have. Average power and RMS value. So this is the power and Parseval theorems. Okay, for the average power and RMS value, so you have three formula for a linear circuit given the input voltage and current given in the amplitude phase form. Okay, so this one is the voltage, current, and the voltage. Okay, for the current is IT equal to I naught plus the summation of the IM cos m omega naught t minus this is the phase of the current. And also voltage is V out plus summation of the Vn cos n omega naught t plus the phase. Whereas the average power is P equal to 1 over T naught integration from 0 to t naught vi dt. Okay, this is the formula. Okay, and then there's one more formula, is this one. Average power absorbed by the circuit due to the periodic excitation. P equal to VDC IDC plus the half of the summation Vn In cos phase for the voltage function. This is the phase of the voltage function minus phase of the current function. Okay, so this one you will have to refer to the equation given by the question. So next is the RMS value. Okay, for the RMS value, the formula is x RMS equal to 1 over t naught integration from 0 to t naught x square. Okay, x square dt and then square root. So this is the RMS and this is the amplitude phase in trigonometry form. This is another formula.
Doktor,
Ha.
maaf ganggu doktor. Doktor tak tukar slide lagi.
Oh ya ke? Alamak.
Ha.
Okay, thanks for reminding me.
Okay, masih doktor. Sorry, doktor ganggu tadi.
Okay, tak apa. So this one is the average power lah, average power that I told you before. Okay, that this one average power MS value. Boleh nampak lah sekarang? Now you can see, right?
Boleh doktor.
Okay, for the average power and MS value, so this is the voltage, is the current and the voltage. Okay, also this one is the average power formula, the one I just explained just now. And this is the average power absorbed by the circuit due to the periodic excitation. Okay, this one also available in your module, which is page 152. And next one is the RMS value. Okay, this is the formula for x RMS. And this one is the amplitude phase and the trigonometry form. So you can calculate the x RMS using this formula also. This one. This one is amplitude format. This one is the exponential format. Okay, exponential form. So there are a few formula for the RMS value. Next one is the Parseval theorems. So Parseval theorems that if the xt equal to it, the current through the resistor R. Okay, if xt equal to it is the current through the resistor R, then the power dissipated in the resistor is P equal to R I square R IMS R I RMS square. So if the xt is Vt is the voltage across the resistor, so the power dissipated in the resistor is P equal to VRMS square divided by R. So it's a little bit different. One is assume I is equal to IT or X equal to IT, and another is XT equal to VT. Okay. And lastly is the power dissipated by the 1 ohm resistance is this formula. A naught square plus half of the summation of the AN square plus BN square. This one also the same, the alternative equation. Okay, let's look at the example first. Example 3.18. Okay, let's look at the example 3.18. Okay, example 3.18. Okay, page 154. So here mentioned Vt equal to 30 plus 20 cos 60 pi t plus 45 degree plus 10 cos 120 pi t minus 45 degree watt. Okay, because it's a voltage, right? And for the current is 6 plus 4 cos 60 pi t plus 10 degree minus 2 cos 120 pi t minus 60 degree for the ampere. Okay, here I want you to find VRMS and then IRMS and the average power. This is absorbed by the circuit. So we now find the VRMS. Okay, we can refer to the formula of the RMS. Okay, we can use the equation 3.46. We can use the equation 3.46 where VRMS equal to A naught square plus half of the summation when n equal to 1 to infinity AN square plus BN square, then square root. So A naught here, this is let me use different color. Okay, A naught is refer to this one. Okay, this is A naught. A naught is 30 square plus 1 over 2. AN is 20. This is AN 20 plus BN is 10. 10 square. So this will equivalent to 33.9. Okay, for the IRMS, also the same. We have A naught plus half of the summation from n equal to 1 to infinity AN square plus BN square. Okay, now A naught here is 6. Okay, AN is 4. BN is negative 2. So 4 square plus negative 2 square. So you will get 6.7. So now next we want to find the average power. Average power you can get it from PDC, IDC. So you can use the equation 3.44. So P equal to VDC IDC plus half of the summation n equal to 1 to infinity Vn In cos theta n minus phase. This one is for the current. So VDC is 30 and 6, right? So 30 and 6, half of the Vn Rn. Vn is just now is 20 and the 4. Okay, cos 45 and 10. So it's 20. Vn In is 10 and 4. 4 cos. Okay, for the voltage is 45. For the current is 10. Okay, plus with again we have another side Vn 10 and negative 2. Okay, for the cos negative 45 and negative 60. So we plus with 10 negative 2 cos negative 45 minus negative 60. So we just simplify. So you can calculate, at the end you will get 203.1 watt for the power. Okay, class? Is it okay? You just
Okay.
follow the formula, you get the VRMS, IRMS, and the power, average power. We still have 15 minutes. I think I can explain about the circuit application, which is the last part of the Fourier series. Is it okay, class?
Okey, Doktor.
Can, not saturated yet, right? Okay, let me off the screen first. The circuit application. Okay, circuit application means that we use the voltage and power in we use the Fourier series to solve the circuit application. This means that we have the Fourier series, right? We have the Fourier series, and we use this Fourier series in the application of circuit. So we want to solve using the Fourier series. Okay, so this is a step using the Fourier series to solve the circuit. Okay, first of all, you need to change the function into amplitude phase form and phasor form. Number second, transform the circuit into time domain to frequency domain. Number third is find the response for each DC and AC component in the phasor form. And the fourth is add the both components and change back to amplitude phase form. Okay, it was look complicated also. Alright, so this one is a step lah. Just now I explained to you. Okay, first how you change the function into amplitude phase form. So this is the you change. Okay, for example, you have the VT like this and IT like this. Okay, so you change to amplitude phase, so it means that you have the amplitude and the phase. So you get a Vn and amplitude, and this is the phase, which is equivalent to An minus jBn. Okay, for the voltage, for the current, okay, In, this is the amplitude, and for the phase, also equal to An minus jBn. Okay, for the phase is negative inverse tangent Bn over An, similar to this one. So this is a formula. I think this one is quite familiar with you all. For the step 2 is transform the circuit into frequency domain. So circuit, if resistor, we still remain resistor R. For the inductor, we can change to L is inductor, we can change to J omega N L. For capacitor, we can change to C. Okay, C is 1 over J omega NC. And omega N is referred to N omega naught. And lastly, we have the impedance Z. Is the summation of these three. Okay, step 3 is to find the response function. Okay, for DC component, always n equal to 0, omega n equal to n omega naught. Okay, always equal to 0 because n is 0. For AC component, you need to find the response of the n harmonic, then change the response function into phasor form. Okay, step 4, add both the DC and AC component. Okay, so you add together, so you should know that this one is the DC component and this one is the AC component, as I mentioned to you before. So lastly, we look for the one example before we end. Okay, this example, the input to the RC circuit is Vs is 1 over 2 minus 1 over pi. Okay, in your module page 157, please change it. Okay, there's a typing error at 157. Everyone, please look at the 157, page 157. Okay, there's a typo error here. This one should be pi. Okay, pi. So it's a typo error here. 1 over 2 minus 1 over pi summation 1 over n sine 2n pi t. Okay, and this is the output. Determine the output. Here is the output. Okay, we have the input source and we have the load. So we want to find the output at the capacitor. Okay, so we will discuss this question. Can you see my screen?
Not yet.
No.
Okay, right? Okay, so based on this, for example 3.19, so the first step is to change to amplitude phase form. Okay, my step here was slightly different from the step in your module. Maybe later I will share again. My solution, which is I writing right here. So I will share again, slightly different from the solution in the module. Okay, so the first step is to change to amplitude and phase form. Amplitude phase form. So VS, okay, VST. The VST is given by the question. Okay, VS is given by the question. So VST equal to the half minus 1 over pi summation n equal to 1 to infinity 1 over n cos not cos sine 2n pi t. Okay, so I want to change it sine to the cos, so this will equivalent to 1 over pi summation 1 over from 1 to infinity 1 over n cos 2n pi t minus 90. Okay, if you are not sure that it's plus minus 90 or minus plus 90 or minus 90, actually yesterday I share with you a YouTube video, okay, how to change not how to change, how to plot the graph using the calculator, right? You still remember yesterday I sent you the WhatsApp? There's a video. This video show you how to plot the graph. Okay, they have the value here. So actually you can key in the value. You can key in sine, for example, for the calculator. You can go back and check. Okay, for example, you use sine x. Fx is the sine x. Okay, so the x is starting from 0. Starting from what is this? Starting from 0 to 360, and then each interval is 30, for example. Interval, this is interval. This is the start, and this is the end. Okay, so this is the, for example, is the fx equal to sine x. Okay, you want the calculator to plot from 0 to 360. Okay, and then each interval is 30. Okay, and then another formula, another graph you want to ask the calculator to plot is gt. What happened? Gt, gx lah. Gx equal to cos. Okay, 2 pi cos x. What happened? Okay, is cos x minus 90. Okay, cos x minus 90 degree. So you also set the start, that is start from 0 and then end at 360, and then the interval you set at 30 degree. So then you plot the graph. Okay, so actually these two graph f and g will give you the same value. This means that these two graph is the same. Cos, okay, cos x same as the cos x, sin x equal to cos x minus 90. Okay, you go back and check. You can refer to the YouTube video that I shared with you last night. Okay, how to check if I want to change from sin to cos. Okay, this is one method. Another method is I can draw the graph of the sine. This is the sine, right? And I draw a graph of the cos. Okay, for easiness, actually you also can determine this is my sine graph, left hand side, and if I want to change to the cos with the phase changes, so I should, this is the change of for the cos is the version of the phase change. Okay, phase change of 90. So if this one, if you look at here, this is 0. Okay, this is 180, so 90 is just half here. Okay, so if that is the case, I should for the, this is the sine, if I want to get the cos, so actually it's a minus 90. Okay, I minus 90, the cos minus 90, I will get the sine. It's the same things lah. Okay, so this one is in the, you use the graph, okay, to understand, to identify which plus 90 or minus 90 degree. Okay, or you can check with the calculator whether these two graph is the same or not. Okay, if you're not sure. So okay, after this one already, you can check this one, you will get the same answer. Okay, these two graph you will get the same answer. All right, and then after that you can change to a this is the amplitude phase form. You can change to the phasor form. You can change to a phasor form for n equal to 1, 2, 3, and then Vs theta, okay, Vs theta equal to negative 1 over n pi. Okay, negative 1 over n pi, because this one, right, negative 1 over n pi. Okay, and then with the degree is negative 90. Negative 90 you obtain from here lah. Okay, so this is the first step. Step number 2 is you transform the circuit, okay, into frequency domain. So okay, just now equation already mentioned omega n equal to n omega naught. So you have the n 2 pi. Okay, n 2 pi, the r you obtain, r is r you have to refer to the circuit. Okay, the circuit just now is in the module is 2 ohm. 2 ohm, so r is 2. C equal to j omega nc, which is j 2 pi n c. C is referred to, okay, the capacitor is 1 farad, so you get 1 So equal to j 2 pi n. So this is the second step. The third step is the response function. Response function I equal to Vs over T divided by Z. Okay, the impedance. Okay, the impedance here, you are talking about the voltage V out at the 1 farad, right? So you are talking about the C. So Z, okay, we actually is the impedance of total. So it's R plus C, because if you look at the circuit, you have the, if you look at the circuit here, okay, you have the resistor and capacitor. So you must plus the impedance is R plus C. So R plus C equal to 2 plus 1 over j 2 pi n. So you can simplify, you get 4j pi n plus 1 divided by j 2 pi n. So this is the Z. So the output V out equal to Vs over Z multiplied with C, right? So Vs is still Vs. So you have the Z is 4j pi n plus 1 divided by j 2 pi n. You multiply with the C. You multiply with the C because the V out here, is accounting for the C, capacitor. So C is 1 over j 2 pi n. So you can simplify, cancel out, we get 4j pi n plus 1. Okay, this is the output V out, and we want to do it in the phasor form. Okay, so phasor form, you have 4j pi n plus 1. Okay, this is equal to an minus jbn, also equal to vn with the phase is theta n. So if you look at here, we can 1 minus, because an minus jbn, right? So we have minus. So a minus j 4 pi n. So we know that the an is 1, bn is minus j 4 pi n. So vn equal to an square plus bn square. So 1 square plus 4 pi n for theta n is negative inverse tangent bn over an. Negative 4 pi n divided by 1. So you get negative inverse tangent negative 4 pi n. So you have V out equal to VST. So this one, okay, V out equal to Vs over this one, right? We can change the lower part to phasor form. So it's 1 plus 16 pi square n square square root, and the phasor form is negative inverse tangent negative 4 pi n. So this one negative actually we can change to positive. Phasor tangent 4 pi n. Okay, so this is the V out, and then we want to get the DC component. We're going to get the DC component when n equal to 0. So VST, okay, DC component when n equal to 0, let's say this one, you change to 0, 0, what do you get? So this one I left 1 only, so this one, here I would left just 1 over 2, okay, because this part I will just give 0, okay. So V out, I will get Vs 1 plus 16 pi square 0, and then inverse tangent 4 pi 0. So I get half. For the AC component, V out T equal to, okay, AC component V out T, I have a negative 1 over n pi negative 90 divided by 1 plus 16 again, n square, and then for the phase is 4 pi n. So this one I can simplify into negative 1 pi n divided by 1 plus 16 pi square n square square root. Okay, for the phase I can simplify into 90 minus negative 90 minus inverse tangent 4 pi n. Okay, so this is the AC component. Then you can continue with step 4. Add the both DC and AC components. So here V out T equal to half plus n equal to 1 to infinity. So you can add together negative 1 over n pi. You multiply with 1 plus 16 n square pi square square root, and then with negative 90 degree minus tangent 4 pi n. So this part is referred to the Vn, and this part is referred to the phase. Okay, so lastly you can change to amplitude phase. Where the xt equal to a naught plus the summation from n equal to 1 to infinity an cos n omega naught t plus phase. So vst equal to half plus the summation n equal to 1 to infinity. Okay, you copy down from the above, negative 1 n pi 1 plus 16 n square pi square square root, and then this one is cos 2 pi nt minus 90 minus tangent inverse 4 pi n. Okay, that's all. A little bit long, but you can follow the step lah. Okay, class?
Okay, Doktor.
Okay, I think we finished or not? Yeah. Oh, last part is the application of the Fourier series in filter. So if the transfer function of the filter is known, the Fourier series can be used to determine the output of the filter. So this one also using the, just now is low pass filter, now is the band pass filter. And this one, okay, this example is similar to the example 3.20. Okay, if a sawtooth waveform is applied to an ideal low-pass filter with the transfer function given below, determine the output. Okay, it's already given the sawtooth and the amplitude and also the signal xt. So what will be the output? If we refer back to the page 159, okay, this is the solution is said that the period is t equal to 1. Okay, the period is t equal to 1, correct? And the fundamental frequency is omega naught equal to 2 pi. Yeah lah, omega naught is 2 pi over t naught, right? So t naught is 1, so it still remain 2 pi radian per second. Since the corner frequency of the filter is omega c equal to 10 radian per second, so refer to this one, 10 radian per second. Only the DC component and harmonic with n omega naught less than 10 will be passed. Okay, so that more than 10 omega naught will not be able to pass. So for n equal to 2 means that you have the 2 omega naught. 2 omega naught is omega naught is 2 pi, so you have 4 pi. 4 pi equal to the 12.5 radian per second, which is higher than 10 radian per second, meaning that the second and higher harmonic will be rejected. Okay, because once n equal to 2, you refer to 12.5 radian per second. Okay, which is more than this one. So you only can get one only. So only the DC component and fundamental component will be passed. So yt equal to half minus 1 over pi sine 2 pi n. This one. 1 over half minus 1 over pi sine 2 pi n. Okay, for this one cannot because 2 omega naught already over the amplitude, already over the size, because you get 12. 12 you get 0. Therefore, you only get the half only. Okay, so this is about the example 3.20. Any question to ask before I ask you to do the tutorial? So for the exercise, please do exercise 3.5. Question 1. Also submit on, just now I said what? 22, is it?
Yes, Doctor.
Okay. Submit on 22 December. Tutorial 3. Okay, perhaps you do question Q2 only lah, because you already have a few questions before. So you just do the Q2, also submit on 22 December. Okay, others you can do also, but I'm not request you to submit. Okay, you have 4 questions. All right. Okay, any question to ask?
Doctor, tutorial 3, question 2 only.
Yeah.
Okay, Doctor.
Can I add another one? Question 4. Question 4. State the two conditions of distance of Fourier series and consider the signal. This one. develop exponential form, and illustrate the amplitude phase. Okay, 2 and 4, sorry. 2 and 4. Okay, so I think that's all for today's lecture. If you have no problem with that, then I shall take the attendance for all of you.